This video will cover the topic of unit conversion, being able to move between metric and English systems of measurement. It is also useful for going between prefix multipliers such as kilo, centi, milli, and other prefixes used in measurement systems. To help us understand this concept, let's look at an example problem. Let's say I want to run a 5K race and my typical race pace is 6.5 miles per hour. How long will it take me to run the race? The first step in setting up these problems is to look at what you know and what you want. In this case, we know that I want to run a 5K race. And I want to know how long it will take me in minutes. There are several other helpful pieces of information along the way. I know that I run at a rate of 6.5 miles per hour. And we also know some tables from our textbook that let us interconvert between English and English and metric systems. And this table indicates that 1 kilometer is the same as 0.6214 miles. A helpful math trick to remember is that you can divide both sides of an equation by a number and the equation is still true. So if I divide both sides of this equation by 1 kilometer, the left side, the kilometers cancel. 1 over 1 is the same thing as 1. I get a number that's worth 1. Notice I also could have divided both sides of the equation by the miles. And I also would have gotten a number that is equal to 1. Except on this time, it would be the right side of the equation where the number would cancel. Both the number and the units cancel, so that is equal to 1. The question is, which of these conversion factors is useful to use? I was given a number in kilometers, so I would like kilometers to cancel. Notice that any number by itself is the same thing as that number over 1. Between these two, I want the kilometers to cancel, so the one that I'm going to use is the fraction that has kilometers on the bottom. This allows me to cancel out the kilometers, and I have effectively converted 5 kilometers into miles. But I'm not done. I want to go from miles to minutes. I currently have 6.5 miles per hour. Notice that this could have come from an equivalency similar to the ones we just wrote of 6.5 miles equals 1 hour. Notice it is like we said this equation equals 1, and I multiplied both sides by 1 hour. But notice if I've got this equivalency, I can now divide both sides by 6.5 miles. And again get 1. So to get my miles to cancel out, I can multiply by this 1 hour over 6.5 miles. Notice the take-home message here. The take-home is that you can take any fraction and flip it over, and as long as the units stay with the number they started with, that is a legal move mathematically. We will take advantage of this frequently in this course. Notice by putting that equivalency in, miles now cancels out, and I now have hours, which at least is a unit of time, so we're going in the right direction. We know that 1 hour is the same or equals 60 minutes. Oops, what did I do? If I do that, what happens to my units? I end up with hours square per minute. I don't know what an hour squared is, do you? This tells me I set this up backwards, so I need to flip it over. I need 60 minutes per 1 hour. When I do that, the 1 hour cancels out, and I am left with units of minutes, which is exactly what I want. So now comes the fun of plugging into my calculator. So we have the 5 kilometers times 0.6214 miles times the 60 minutes. I prefer to do all the multiplications across the top first, and then the divisions, and the one division we have is 6.5 miles, to get us a time of 28.68 minutes. Hey, wait a minute, we better think about sig figs. Let's look at our problem again. There are 2 sig figs in the distance, 2 sig figs in the pace, which suggests there should be 2 sig figs in our answer. So my answer should be 29 minutes. Notice this 0.68 rounds up.